And for question 8, we are going into probability distributions, and in part A, we are given this standard normal distribution curve, right? Standard normal distribution curve, right? So before we continue this question, let us understand what is this. What is standard normal distribution, right? So this curve is actually shown in the diagram here, right? Which is this one. So this curve actually has a bell-shaped curve, and if we use the f of z axis here, or meaning the y-axis here, if we split this curve by half, left side and right side will have the same shape, which also means this curve is symmetric. Right, it's symmetric because if we use this line here, this axis here, and we split it by half, left side and right side will have the same shape. Alright, so if both sides have the same shape, means that the area which is under the left side of the curve here, right, the area here, and the area which is under the right side of the curve, which is here, right, both sides, left and right, will have the same area, right? So we know that for this curve, the area, right, the total area here is 1. So if we split this curve by half, the area will also split by half, which means the left side here, the area would be 0.5. Right side here, the area would be also 0.5. Right? So since the areas are the same, and this curve actually helps us to find out the probability, so the probability will be the same as well for left side and right side of the curve. Okay, so this is another characteristic. Since it has the same shape, meaning it has the same area, meaning it has the same probability for both sides. Alright, so these are the properties of a normal distribution graph or curve. Right, but before we continue the question, I just want to let you know, for normal distributions, there are actually two kinds of curves, right? So one is called the standard normal distribution curve, and the other one is called normal distribution curve. So this one is without the word standard, right? So is there a difference? Yes, there is. So standard normal distribution curve, right, as you see in this graph here, it uses Z. Okay, so standard normal distribution is Z. For normal distribution curve, it uses X. Alright, so let us draw out a normal distribution curve first. Right, so the x-axis here, it would be using X. Right, and then there will be this bell-shaped curve here. But the difference is, whether it has the y-axis or not depends on the normal distribution, right? So let's say the mean here, right? The mean here is 50, right? The middle line of the curve here, it will use the mean. But if you see the standard normal distribution, it will always use 0 as the middle line. But for normal distribution curve, it uses mean as the middle line. Right? So this is the main difference between these two curves. One uses mean as the middle line, the other uses 0 as the middle line. Right? But you will be asking, why we need to learn X and Z? Okay, once we completed the discussion of this paper, I'll explain why. Right? So let me put a note here in case I forgot. Right? Okay, so let's go back to the question here. So we have a standard normal distribution curve and we are given this probability. Right, so this probability is where the small z here is between 0 to k and it's 0.3125. So let us match this probability to to the diagram here. So where z is between 0 and k, which is here, right? This part here. Okay, so we know that this part has a probability of 0.3125. Okay, and now in the question tells us to find out the probability where z is greater than k. Right, so let us also identify this area in the diagram here. Right, so to find out the area, usually what I will do is I will use this inequality as a direction. Right, because this greater than here, it's like we are moving to the right side. Right, because it's pointing to the right. So we are going to start from k, and then we are going to draw it to the right side. We are going to move to the right side. So from k, we are going to move to the right side. Right? Move to the right side. So this is the area that we are trying to find, or the probability that we are trying to find. Right, so just now we have mentioned that this curve is a bell-shaped curve, meaning it is symmetric, meaning left side and right side will have the same shape, same area, same probability. And just now we have found out that the right side here, the probability is 0.5. Right? And in the question, they also gave us the probability of this blue color area here, right? Which is this value. So if we want to find out the pink color area's probability, we can just use the probability of the entire right side here minus of the probability of the blue area here. Okay, so here let us write our working. So we need to find out the probability where z is greater than k. So it would be the probability of the entire right side here, 0.5, and minus out the probability of the blue area here, which is where probability where z is between 0 and k. Alright, and then we are going to substitute its probability here, which is 0.3125, and we minus them together, we will get the probability 0.1875. And for part B, it says the mass of the students in a school is a normal distribution. Right? So here it doesn't say standard normal distribution, it says normal distribution. Right? So this actually follows X. Right? Because Z is using standard normal distribution. Right? So meaning this mass of students in a school is our X. Okay, so let us write it here. X is the mass of students in a school. Right? And this X has a mean of 55 kg and a standard deviation of 10 kg. Right? So in part 1, we need to find out the mass of the students if the standard score is 0.5. Right? So what is standard score? Right? So you see there's actually the word standard here. So it's actually the value of Z. Alright? The value of Z, which is called the standard score. So now, how can we use this Z and we find the mass of the students, which is actually X? So Z, how do we change it to X? Okay, so we need to use this formula, which is Z equals to X, which is the mass of the students, minus out the mu, right? So this is pronounced as mu, mu, and it's actually the mean. So in our situation here, it's the mean of the mass of the students in a school, right? Which we are given here, which is 55 kg, right? So this is actually our mu. Then we are going to divide with sigma, right? So it's called sigma, sigma, and this is actually the standard deviation, right? The standard deviation, and it's also given here, which is 10 kg. So this is also our sigma, right? So we have the value of Z, we have the value of mu, we have the value of sigma here. So let us substitute all of the values inside here to find out the X. Okay, so Z here is 0.5, X will remain the same, mu will be changed to 55 and the sigma here would be 10. Alright, so now let us move this 10 to the other side and the negative 55 to the other side. So our x value would be 60. Right? So with a standard score of 0.5, our mass of a student would be 60 kg. And for part 2, we need to find out the percentage of students with mass greater than 48 kg. Right, so before we find out the percentage, let us find out what is the probability first. The probability where the student has a mass greater than 48 kg. Right, so now to solve any kind of normal distribution question, we are going to use this method, which is called the 5S method. Right, so the first S is statement, which is called the probability statement. So meaning, what is the probability that we are trying to find now? Right, so now is the probability where the student has a mass, right? So mass is X, right? Greater than, right? Let us change this into an inequality, and it's greater than 48 kg, right? So we are trying to find out the probability, which is P, where X is greater than 48. So this would be our probability statement, the probability that we are trying to find now. Okay, so this is for the first S. So now let's go to the second S, which is to search. Search meaning we are going to search the parameters in normal distribution, which actually we've already found, because the two parameters in normal distribution is actually the mu and sigma, right? Which we have already done, 55 and 10. And the third S is standardize, right? Standardize means that we need to change X to Z. But in part 1, we already done something similar, right? Because just now, we are changing Z to become X, right? So now it's the other way around. X, we need to change it to Z. So we can also use the same formula, right? And you realize that this is highlighted in blue because this is the formula to standardize. From X, we change it to Z, right? So here, let us change our X here to become Z. So let us use this formula. So X now is 48, right? And we minus with the mu, which is 55, which is our mean. And we are going to divide with the sigma here, which is the standard deviation, which is 10. Okay, and let us simplify this and we will get negative 0.7. Right, so now let's go to the fourth S, is to sketch. Right, so from this probability, we need to sketch out a graph to see how can we find out the probability of this result here, Z greater than negative 0.7. Right, so this will be our normal distribution graph, right? It's a bell shape and it's symmetric. Left side and right side will have the same shape. And now let us label the value of Z that we have here, which is negative 0.7. So since this is a negative value and 0 is the middle line, so it should be at the left side of the graph. So it would be somewhere here. Alright, somewhere here. Oh, sorry. Let me change the color a bit. So to sketch the area, we can look at the symbol again, right? So this is greater than, so it's second direction that we are going to the right side. Okay, so means we are starting off with negative 0.7 and we are sketching to the right side, right? We are going to the right side. So our area would be something like this. Okay, so now this is the area that we are trying to find, or the probability that we are trying to find. And for the last S is to select, right? So select means using this shaded region here, we are going to the normal probability distribution tables to find out the correct probability, right? But first, we need to make sure this shaded region here satisfies these two criteria. So the first criteria is it must be one-sided. So means the shaded region here, it must be either left side or right side only. It cannot be both. And the second criteria here is the shaded region must connect with the right end. So right end means here, the right side of this graph. Okay, so if the shaded region touches the right end here, means that it is satisfying the second criteria. Right, but if you look at the first criteria, actually we already failed. Right, because you see the shaded region here, left side and right side is involved. It is in both sides. So we cannot use this shaded region to find out the probability in the tables later. Right, so how are we going to do this? So let us change our focus. Right, so instead of finding the probability of this shaded region, why not we consider the probability of the entire graph first? Right, the entire graph first, which is 1. Right, and then since it only can find probability where the region is one-sided only, we can focus on this small part here. Because this part is actually one-sided, it's only appearing on the left side. So if we can find out this probability and we can minus this with 1 here, then we can find out the probability of this shaded region here. Okay, so now instead of finding the probability of this shaded region here, let us find the probability of this small part here. Okay, so if we use this small part here, we actually satisfy the first criteria already. But the issue is the second criteria. It is not at the right end, it's on the left end. It's on the other side. So how are we going to do this? Alright, so let us recall back the properties of a standard normal distribution graph. The graph is symmetric. Left side and right side will have the same shape. So if we are finding the area of this small part here, it is actually the same area on the right side. Right? Because again, left side and right side will have the same shape. So means the area here and the area here will be the same. So what we are going to do is we are going to move this green area here to the right side of the graph. Right? From here, the left side, we move it to the right side. Because again, this graph is symmetric. Left side and right side will have the same shape. So if the same shape, meaning same area, meaning same probability. Okay, so now we have moved this green region here to be on the right side, and you can see that it connects with the right end of the graph. Right, so we have satisfied both of the criteria here. Okay, so now for the value of z here, what would it be? Right, because now this value is on the right side of the graph already. Previously it was negative 0.7. So now we just remove the negative only. Right? Remove the negative, then it will be 0.7. Okay, so what is the probability that we are trying to find now? So again, we are finding the probability of the shaded region, right? So using 1, which is the probability of the entire area here, and minus out with this green area here, which is the probability where z is, because this shaded region is going to the right side, so it would be the probability where z is greater than 0.7. Right? Greater than is because it's like an arrow moving to the right side. Right? And here, our shaded region is sketching to the right side. Right? To the right side. Okay, so now our probability would be 1 minus probability where z is greater than 0.7. And since this region satisfies both criteria, let's go to the tables to find out the probability. Alright, so we are given the value of z, which is 0.7, and let us find out the probability. Right, so this table here is actually a snapshot of the standard normal distribution table, right? And it helps us to find out the probability using these two steps, right? So the first step is to match the first 4 digits of z onto this table here, right? So this table, it is split into 3 sections: section A, section B, and section C. So using the digits here, we are going to match it to A, B, and C here, right? So for the first 2 digits, which is 0.7, we are going to match it with section A, right? So let us search the value of 0.7. Alright, it's here. So this means when we are finding the probability, we need to focus on this row, right? This row. Okay, for the next digit is 0 and it follows section B. So since the value here is 0, so we are looking at here, right? So meaning we are looking at this column. And for the last digit here is also 0 and it focuses on section C. But if you look at the values here, none of them is 0. Okay, so meaning we are not going to look at section C, okay, because there's no 0 here. Alright, so now we have identified the rows and the columns that we need to see, so let us look at what is the value that we are trying to find. So using this row, using this column, means that we are looking at this value here, 0.2420. Alright, so this is the first step. According to the digits here, we try to find which is the column and the row we need to look at. Right, so now the second step is to minus. Right, so this minus actually means if we have a value in section C here, we are going to minus with our value here. But since the value of C here now, the value of the last digit here is 0, so means we don't need to minus anything. So it would be minus 0. Okay, so we minus these two things together, then it would be our probability, right? So our probability would be 0.242. Okay, so now let's get back to find out the probability. Alright, so from the tables, our probability is 0.242, and if we minus with 1, then our probability would be 0.758. Right, but that's not all. Let us recall back the requirement of the question. It says we need to find out the percentage of students. Alright, so let us just convert this decimal into a percentage, right? Which would be 75.8%. Right, so it means 75.8% of the students with a mass greater than 48 kg. Right, so as promised, let me explain why we need to learn X and Z, two different kinds of normal distribution curves. Right, so let us understand a bit of Z here. So if we draw the standard normal distribution graph, right? Okay, this is the curve. So the middle line, which is this axis here, it always has a value of 0. This means the mean of Z here will always be 0. Alright, for X, X can be a lot of things. For example, just now, the mass of the student. So the mean can be 50. But maybe we have another set of students with a different mean. So the mean can be 55. Or we have another set of students where the mean can be 60. Okay, so now let's imagine we don't have Z, right? We don't have Z. So using these means, how do we find out the probability? Right? So let's say for me 50, we can use this table, right? But what if the mean changes? Can we use back the same table? No, right? Because the probabilities depends on the mean. So for mean 55, we need to use another table. And for mean 60, because we changed the mean again, then we need to follow another table. So if we have 3 mean values here, we need to have 3 tables. But this mean will not always be a whole number. It can be a decimal also. So for example, 50.1 or 50.12 or 50.123 and so on. So if you look at all the possibilities of mean, there would be a lot, and each of the mean here will have its own table. So you can imagine that there's a lot of tables that we need to refer to, but it's just finding out one value only. Very, very time consuming, right? So this is where Z comes in. Why we need to do the third step in the 5S method, which is so standardized, is because we can change all of the mean values here to follow just one simple value, which is 0. So we don't need to refer all of the tables from these means. We follow the one simple table that uses 0, which is this table. Okay, so to learn Z is because it helps us to save time to find out the probability.